And welcome everybody to the Daily Space Weather Show. I'm your host, Dan, a.k.a. Smash a Match, coming at you from the Smash News Network. These busted name of news. We've got a higher likelihood of large solar flares. We've got climate. And coronal mass ejections, some of which are quite spectacular. One of which is occurring as we produce the video. This is the past 24 hours from SDO, the Solar Dynamics Observatory. And today we're looking at two species of ionized iron. So you can see up there in the upper left corner there, the northeastern limb, there is a CME indeed propagating at the moment. Now there is also a fleeting possibility of a large solar flare on the northwestern limb, just above the Earth scale up there. However, that will subside throughout the day today. And we'll be left with a very high likelihood of large solar flares, including the possibility of X-class solar flare events from that eastern limb. 4 brand new, recently named sunspot groups showing up over there. And some of those are quite magnetically complex. Also a huge plasma filament, which we'll talk about later. Here we've swapped out the 131 angstroms for 211 angstroms. And let's talk about sunspots here briefly. Before we do any of that sort of stuff, take a moment to visit our links. So we do have a homepage that we launched back in 2019 in response to the ridiculous censorship of Facebook, now known as Meta, one of the 4 evilest companies in the world. You can also find links to our merch shop, our Amazon storefront, our Hemp Lucid shop, the Redbubble shop. That is the merch shop, by the way. Multiple links there also to the Smash team. We'll talk about that later in the video. By the way, thanks to the Smash team members for increasing the probability these videos will continue to exist, remain publicly visible, and free for all to view. So here's yesterday plus today in the SDO continuum. And again, 4 significant sunspot groups over here on the eastern limb. Here's colorized magnetogram for that same period, July 27th and July 28th to date. So besides those newly named groups over there, no major changes happening. And as far as volcanic activity, the Fagradalsfjall complex here, it looks like it's shutting down operations. So if you go back to when it was dark in Iceland, you can see just a slight lava flow which is crusting over here. So looks like it may be slowing down, although there's some explosive activity happening. So, yeah, but as far as the overall scenario there, it looks like it is subsiding as far as that eruption in the Fagradalsfjall fissure complex. As far as what else is erupting, I'm interested. What about you? Shivaluch, now back on the list on the Kamchatka Peninsula. New lava dome growth appears to ooze as erupted lava, giving it a smooth egg-like shape. So perhaps a new eruption about to happen there. A thermal anomaly also detected in the area of the Karen Dome. Yeah, the Karen Dome. Karan Dome? Karan Dome? I don't know. Mayon in Philippines also erupting, producing an unknown volcanic ash plume. Please do not fly your hang glider over the Philippine caldera of Mayon. Luitolo exploding, producing a 6,200-foot plume of volcanic ash there. Fuego exploding in Guatemala, flight level 150. It's a 15,000-foot ash plume. Nevado del Ruiz exploding. It is a 20 to 22,000-foot ash plume, flight level 220 there over Colombia from Nevado del Ruiz. Increased number of earthquakes also suggesting more fluid motions and gas and water below the surface. Sabancaya exploding, flight level 230 over Peru from Sabancaya, and flight level 210 over Ubinas. So 21,000-foot ash plume over Ubinas, 23,000-foot ash plume over Sabancaya, and next we've got earthquakes. So there's the convenient 90-day bar graph for you, and here is the quake rundown of earthquakes of a 5 magnitude or higher. So there was a 5.3 at Russia. That is northeast of the that's northeast of Japan, actually. South of the Fiji Islands, there was a 5.4. That was 11:43 Universal Time yesterday morning. Central Mid-Atlantic Ridge had a 5.1. That was at 2013 yesterday evening. And then about 2 hours later, a 5.0 at Vanuatu. And then only 3 minutes later, a 5.0 at India, near the Indo-Asian plate boundary. There was a 5.6 at the southwest Indian Ridge. There it is at 7:03 this morning. A 5.4 right in that same location. Might be an aftershock there. Nope, looks like it was a foreshock. So check it out. Then there's a 5.9. So keep in mind that 5.9 could be a foreshock as well. That 5.9 was the largest quake of the past 24, and it occurred at 7:58 Universal Time this morning on July 28th. So let's get back to the sun. Again, we'll be keeping an eye on that eastern limb. It certainly looks like it is exhibiting a high possibility of large solar flares. We'll look at the magnetic fields later in the video. Here's the full disk zoom in the 171 angstroms wavelength from SDO. Next, the 10.7 centimeter radio flux has sort of stagnated here in the past couple days. It's at 165 solar flux units. Don't expect that to continue. That is going to jump up quite rapidly here. With as many sunspots as we currently have, those groups in the east especially will add to the radio flux in the coming days. There is a 1-year graph from Solon.info. The black line is the radio flux, so 165 solar flux units is the current state of that. If you're not familiar with the radio flux, it is a proportional data set to sunspot number. So if you look on the Space Weather Enthusiast dashboard here, you can see how similar radio flux represented by that bottom graph is versus sunspot number. Very proportional data sets. The radio flux discovered back in 1947 by Canadian World War II radio users. They got their hands on some World War II radio equipment and discovered that there was a signal appearing that they weren't expecting. That was the discovery of the 10.7 centimeter radio flux. Space Weather Enthusiast dashboard here, not forecasting any geomagnetic unrest or geomagnetic storm conditions in the coming days. If there are any CMEs headed this way, we'll tell you about it later in the video. So here is the past 4 hours of Earth's magnetic moment from space. This magnetosphere movie depicts magnetohydrodynamic pressure, the units of which are nanopascals. And it is a geomagnetically calm situation. The meridional plane view shows crescent Earth. Yeah, crescent Earth. So yeah, quite geomagnetically calm here for the past 4 hours. Here's Earth's magnetic moment from the ground for the past 4 hours. Our ground magnetic perturbations map depicting changes to Earth's B field in nanotesla. Magnetic flux density. Not a lot going on. Aurora unlikely over most of the planet. KP index is currently only at 0.66. 0.666666666, 0.6, rounded to 0.67 is the planetary K index, an average of global geomagnetism. Solar wind here pretty unremarkable for the past 24 hours. 380 kilometers a second is the speed. Just under 4 protons per cubic centimeter is the density. GOES magnetometers here showing a little bit higher highs and higher lows than the previous days. There's the 7-day graph, and you can see here some increases in the magnetic field there, measured at the near geosynchronous near equatorial geosynchronous orbits of the GOES 16 and GOES 18. Little higher highs and higher lows there in the past 24 hours. Next, the heliospheric current sheet. We do have a continued magnetic battle happening in the northeastern limb. So yesterday we talked about how there is a possibility that when the massive plasma filament up there in the northeast, if that should suddenly reorient itself, collapse, or eject, it could cause some rapid changes to the coronal hole structure, the magnetic field structure of the sun's atmosphere. And you can see that continuing here in the top view ecliptic plane field plot. Bring up the latest image. Earth remains in a south pole current sheet. And it's possible that in just a few hours, Earth could be in a north pole current sheet. Or it's possible that even by the time tomorrow's daily space weather show comes out, Earth could still be in a south pole current sheet. The magnetic environment is basically an environment that can change with no warning, pretty much. But the top view ecliptic plane field plot does give us great predictive value. Here's our line of sight field plot. And again, there is some indecision happening up here around that massive plasma filament, which we named on X. Yeah, on X. Great branding, by the way. Here is our line of sight coronal hole plot. We've got some North Pole coronal holes here that are trying to migrate to the south, it looks like. So if you're new to the channel and you're new to solar cycles, keep in mind, folks, at solar minimum, you've got the fields. The north field is up here. The south field is down here. Throughout the solar cycle, they reverse. And at solar maximum, they should be about in the middle of that reversal process. And we've been showing it on the channel here the whole time. So that's the current situation for coronal holes. And let's take a look at 211 angstroms from SDO. So that's the best wavelength to show coronal holes. And again, we do have mostly North Pole coronal holes, so we've got like a strip of South Pole, like this. These are south. And the rest of these are North Pole. So Earth is right now in a little current sheet associated with those South Pole coronal holes, and that could change rapidly, especially if this filament reorients. So, and that could be a thing that's happening now. It looked unstable yesterday, but it still remained intact here. It looks more unstable today. And let's move to sunspots. So here is our flare monitor wavelength, our flare monitor from the Integrated Space Weather Analysis website. And let's see here. So there's the latest, number 6. So 3386, according to this flare monitor, is the most likely location for a large solar flare. I would say generally the northeastern limb, not just 3386, but also 3387. So this whole area here is sort of ripe for the possibility of a large flare. Let's take a look at some of our favorite imagery here. Here is the SDO intensity gram. Let me speed that up. There's the SDO intensity gram for yesterday plus today. This sunspot down here is a reverse polarity sunspot. So it does have some South Pole umbre to its north and to its west, but the main umbre there is certainly North Pole orientation. So that's an oddball, and this does happen, folks. It's not time to get in your bunker as a result of that or anything like that. Occasionally we see a reverse polarity sunspot. Could be from the next cycle, could be from the previous cycle, could just be an anomaly. Who knows? But the sun does regularly do such things. It is somewhat rare, but not an unheard of thing. So next we've got some more imagery here of sunspots. Here we've slapped together 1700 plus 1600 angstroms. And let's zoom in a little bit closer there. I would say this sunspot does have some flare potential as well, because we do see some evolution of that group. You can see some brightening there in those South Pole umbrae right down here. But yes, the northeastern limb, this area up here, is the most likely place to see a large solar flare. The automated solar flare monitor and I agree on this. So next we'll talk about energetic particles like SEPs. There's the ghost proton flux. We ain't got no energetic particles. Despite 2 M-class flares in the past 24. So here we've put up a 7-day graph of the GOES X-ray flux. And you can see the X-ray profile did come up here. The baseline has moved up in the past couple of days. You can expect this to move up even more here. Again, lots of new sunspots showing up there in the east. So normally we show the 3-day. So there's the 3-day. The largest flare of the past 24 was an M1.75. That occurred. Peak flux was around 2240 universal time yesterday. And let's take a look at some flare wavelengths. So here we've put 1600 angstroms together with 94 angstroms. 1600 angstroms is ionized carbon. And let's zoom in a little bit closer here. So the entire eastern limb does pose some possibility for large solar flares, but again, the northeast is the most likely place. There is a huge plasma filament up there, which we will show you more detailed imagery of here in a moment. Before that, we're going to talk about coronal mass ejections, and before we do that, let's show a star chart. So this is what's happening over Lehigh Valley right now. You press the Now button, and there you go. The sun is only a few degrees here above the horizon. Check out skyandtelescope.org's sky chart if you want to make your own. Saturn setting over there around the western ecliptic. Next, a solar system forecast. Is where things are today. And is where things will be in 1 week. No, the planets are not going to kill you. No, Jupiter and Saturn are not going to turn into stars. So let's move to coronal mass ejections. And we've got some splentacular imagery for you here from George Mason University. So some significant CMEs happening. There's one out of the, looks like the northeast. That's 103 frames from yesterday, July 27th. And here are an additional 31 frames from today. Again, there is a CME happening as we produce the video, I think. So we'll show you the most up-to-date imagery here in just a minute for that. Here's LASCO's two LASCO coronagraphs, C2 and C3. All right, nothing showing up yet. And do we have old data here? Data looks a little bit old there. Let's also take a look at stereo A, which is unfortunately located practically in the same place as Earth at this point. This is stereo A's coronagraph over here. It stands for ahead, but it's not really seeing any space weather ahead of Earth at the moment. It's pretty much seeing the same view as the SOHO, which is located at Lagrange 1, right in line with Earth. And we do not suspect those coronal mass ejections to be earthly directed. So let's show our custom CME videos here. Let's get a little bit closer there to see if we see any indication of Earth-directed CMEs. I don't suspect so. There has been an ongoing outflow down here in the southwest. So this CME out of the west came from this area right here. I suspect that it's slightly behind the limb. I do not anticipate that to be earthly directed. Based on the data that we see, we don't think that is an earthly directed coronal mass ejection. You can see some activity happening up here. Here's the 193 angstroms wavelength from SDO by itself. As we pause for station identification. Thanks for tuning into the Smash News Network, least busted name in news. So right there at the end of the video, you can see some material looking like it's making its way out from the northeastern limb. And this properly gigantic plasma filament here is still looking unstable, but it looks like it's not on its way out yet. So it still does have the capability to reorient itself, collapse, or eject. Those are pretty much the options available to a giant plasma filament. So let's take a look at that in hydrogen alpha from the ground-based El Teide, Spain solar telescope, part of the National Solar Observatory. We've named this one the Nicki Minaj filament. And there are quite a few smaller filaments around both the southern hemisphere and the northwest. So this one certainly has the capability of producing a massive solar storm, a massive geomagnetic storm on Earth if it does end up headed our direction. Fingers crossed for that. Don't worry, folks, it is not going to melt your silverware. You don't need to buy ceramic silverware because that's not a thing. So let's briefly look at that in. There's SDO. We've added ionized helium to the 193 angstroms. And let's zoom in here to show even more detail. That's one of the larger filaments and denser filaments that we've covered on the channel. Once again, there it is from the ground-based El Teide, Spain hydrogen alpha telescope. It shows up as an absorption feature. So it's darker. It is blocking the 6,562.8 angstroms wavelength, the emissions of the hydrogen. And what's next, you ask? Well, I wonder the same thing. The next is, if you don't follow us on social media, why not? If you've unplugged from social media entirely, we completely understand. If you are on social media, why not join us over on X, the brilliantly rebranded, formerly known as Twitter, quote, social media, and quote, platform, and quote, where censorship and shadow bans and deboosting continue, despite delusional cultists claiming that a certain tech billionaire has, quote, fixed free speech on, quote, social media. So break out your, quote, smart, and quote, phone. We're also on Instagram. You can find diet lifestyle posts over there. And before we get to bonus features, let's take a look at the last couple of hours here from the GOES 18 SUVI. So still looking pretty stable here. There is a lot of material stored in that plasma filament, and it's starting to point directly at Earth. So that is the scenario. And let's move to bonus features. As far as satellite charging hazards, we ain't got none. It's smooth sailing. No surface or internal charging hazards for satellites here at the moment. Goes electron flux in a normal operating range here. Looks like it might be a little bit lower than the forecast. That is the 3-day radiographic measurements by the GOES 16 and GOES 18. They measure that at the F layer of the ionosphere. Here's a 1-year graph of the electron flux, kind of right in the middle of the range there. Nothing to write home about. And it looks like the forecast was right on. It'll just be a little bit under the latest observation there, represented by that yellow diamond, the blue, the green. Yeah, I have the blue, green, the green colored boxes. Yeah, those are green boxes. Those are the forecast. The F layer is where it's measured. So we show the vibrational frequency of that entire layer of the atmosphere, one slice, the F layer. Feel free to pause the video on this frame if you're not familiar with the information depicted. Here comes the Australian Bureau of Meteorology's ionosphere data. So that is the previous day. We are seeing some significant anomalies in the ionosphere here. And don't worry if you're not familiar with this imagery. We'll show the anomalygram. That should help clarify things. So that is the raw vibrational frequency. Here's the anomaly in megahertz from a 30-day median. The ionosphere has flipped in some ways. Now we're getting high-frequency anomalies where the low-frequency anomalies were yesterday. So we've got low-frequency anomalies in the northern hemisphere now and high-frequency anomalies in the southern hemisphere. This does depict high-frequency anomalies in blue, low-frequency anomalies in red. So the ionosphere there attempting to reach static equilibrium as it's wont to do. It is the bridge between Earth and space. And it basically is space from an Earthling's perspective because, well, there is not a lot of material up there at 300 kilometers of altitude. There's the latest image, 1115 universal time ionogram and 1115 universal time anomalygram. We also show total electron content, which is free electrons from up at your GPS satellite all the way down to your handset. That satellite must communicate through the inner portion of the outer Van Allen belt, the outer plasmasphere, the inner Van Allen belt, the inner plasmasphere, and the ionosphere. And those free electrons can cause signal refraction. So here is the total electron content forecast, the coupled thermosphere, ionosphere, plasmasphere, electrodynamics model. We're seeing continued anomalies in the southern hemisphere there. Also some anomalies around Greenland, northern Canada. But those are pretty minor. The more major ones are south of the equator, around the southern Indian Ocean, southern ocean, Antarctica, south of Africa, and south of the Atlantic. So that's literally a count of the free electrons between the GPS satellite and ground level. Here is the anomaly from the 10-day average for that same total electron content for North America. Some slight signals here around northwestern Mexico. Besides that, nothing major going on there in terms of anomaly from the 10-day average. And we'll close out the space weather section of the video before we get to climate with the latest intensitygram and the latest magnetogram. So let's briefly look at these sunspots here. That one is beta gamma class. This one up here, also beta gamma class. Now these groups over here, this one here is beta gamma delta class. This one here is beta gamma delta class. This one is beta gamma delta class. That has got an increasing likelihood of large solar flares. And this one over here is beta gamma class. Here's a full disk rock back. This one here is actually alpha class, I think. Only one umbra there. That is an alpha class sunspot. Anyway, that's where we'll close out the space weather portion of the video. By the way, if you enjoy the content, don't forget to press the like button. If you're new to the channel, do yourself a favor and press the subscribe button. Since this is the Daily Space Weather Show, it's the most comprehensive daily space weather and imagery of the sun you'll find in the known universe. We bring the space weather all the way from the photosphere down to ground level on planet Earth. So, once again, thanks everybody for tuning in. And congratulations on realizing that the Smash News Network, least busted name in news, exists. So let's talk about climate. Yeah, climate. Sea surface temperature anomalies are what we're showing here. And check it out. The Gulf Stream is still warming Europe, folks. It's still warming Europe. Do you see a lot of cold water floating around on the surface over here? What's that? No? Me neither. A lot of people are worried about that the Gulf Stream is going to shut down, plunging the Earth into an ice age. I remember in the late 1980s coming home from Earth Science class, telling the parents that, did you know global warming causes global cooling? Because of the melting of the Greenland ice sheets and warm water, cold water being injected into the North Atlantic and causing Europe and then Asia and then North America to freeze. Yeah, that's what happens when the Northern Hemisphere glaciates. So far, I just see a bunch of warm water up here, not a bunch of cold water sitting on the surface, indicating the low salinity of melted snow and ice. So we're showing sea surface temperature anomalies here in ocean currents. There is the full view of the Atlantic. Here is the Southern Ocean. Here's the Indian Ocean. There is the world's largest body of water and largest surface heat sink, the Pacific Ocean, which is very deep and has lots of water and requires a lot of energy to heat up, or consumes a lot of energy to cool down. And here is the Arctic. So that is the sea surface temperature scenario, and of course you may have heard some climate stories in the past couple days. We're going to cover 3 of them here briefly. First, we'll take a look at the wind patterns around planet Earth. So there is the surface wind scenario for the east. Here is the jet stream scenario for the east. Jet stream scenario for the central world. Surface winds of the central world. Surface winds of the Americas, the west. And here are the jet streams. So some significant jet stream anomalies happening here over the U.S. I mean, you can see some real weird signals there in the 250 hectopascal winds. And let's move to climate. Yeah, climate. I don't know if I'm allowed to say that word or not. So first story we'll cover is cactuses are dying because it's so hot in Arizona. Now, in 1998, I went to Arizona, and it was over 130 degrees in Yuma, Phoenix. So that I remember, 130 plus degrees. 134 actually was what the thermometers were saying in Phoenix. 130, 131 in Yuma, Arizona. Anyway, apparently climate change being blamed on the death of some cacti. So, as reported by KRDO.com. Phoenix's record heat is killing off cactuses. Now, I'm not sure how hot it got. Oh, over 110 degrees. This story picked up from a CNN story. So there's one story. Cactuses dying and losing arms as a result of, quote, record and, quote, heat in Phoenix. Also, a world of boiling. This guy standing in boiling water as his legs burn off. This guy running away from a fire probably set by human arsonists, and this person in a rainstorm. A clear indication that the UN director, the UN director, as if that person has any authority over Americans. Check it out. Global boiling, folks. Now, I'm not sure if the sea surface temperature anomalies were over 200 degrees Fahrenheit. I'm not sure if we showed any boiling water on that or not. But here is the UN Secretary General, Antonio Guterres. It's a world of global boiling, folks. Global boiling. And here's a spooky looking graph, in case you weren't frightened that the planet is so hot. So remember, folks, according to certain people, a cooler planet would be safer. A cooler planet would be safer, according to some people. And I'll just leave it there. Also, climate change being blamed for, guess what? Your fungus. Yeah, you might be exposed to deadly candida, also blamed on climate change. So, of course, hot temperatures do allow for faster cellular respiration, which is why we heat up bacterial and fungal cultures to grow them in a laboratory. In 2016, hospitals in New York State identified a rare, dangerous fungal infection known as Candida. Did you know alkalinity affects this? Anyway, also blamed on climate change, according to News 19, WLTX.com, a CBS affiliate. Next, we're looking at mean sea level pressure. And I hope it's not too mean, that sea level pressure. There it is. That is your global pressure map from windy.com. World's lowest pressure here in the Southern Ocean. Multiple spots of very low pressure down there. And a low continues to loiter in between Iceland and Ireland. High pressure anticyclones dominating the northern Pacific and Atlantic. And very high pressure down here in the southern Atlantic. Massive pressure gradient right down here in the Southern Ocean. Continuing right along to look at clouds and fog. Yeah, clouds and fog, we show it daily on the channel. This is 3.9 micrometer infrared shortwave radiation, allowing you to see clouds and fog even at nighttime. And shout out to our viewers from all around the planet. So since it's dark over about half of that map, we show instead of the visible satellite, the shortwave radiation map. There is clouds and fog. You can see that south to north flow happening over Florida and the rest of whatever it shows. So here is the smoke map. This is our smoke forecast map from firesmoke.ca. Quite a bit of fires here in the southeastern U.S., as well as in large portions of Canada, Oregon. So that's your smoke forecast. No real thick smoke is forecasted here at the moment, except for in places like Washington and Oregon, it looks like. Of course, parts of Canada like Saskatchewan, they're expecting some pretty heavy smoke. And let's move on to our weather.gov map. So we've got a bunch of warnings there, mostly heat advisories, since the planet is global boiling is now the new term. Global boiling, folks. Now, what are those warnings in Maine? I think those are fire weather watches there. However, if your location is lit, head to weather.gov. If you can see this video, you can probably access a website, smashomash.com. You can probably access a website like weather.gov and get your local weather alerts from there. So since temperature is so in focus, here's your GFS temperature anomaly forecast in degrees Celsius for the next 72 hours. So that's what's going on. Here is your jet stream forecast for the same period and the same model, the GFS 72-hour 250 millibar wind speed forecast. Jet stream here going to remain mostly north of the U.S., and that's going to keep most of the cool air in Canada. Let us know in the comments if your local lake or stream is currently boiling. Next, our GFS 72-hour pressure and precipitation forecast, and we do have some heavy weather coming to the Ohio Valley and then moving into the mid-Atlantic states. Anyway, I won't try to explain all of that. That's why we show the graphic. Next, your lightning mapper. That's where lightning's been striking for the past about 10 hours. And let's take a look at current lightning strikes as we saw some significant lightning here around Chicago. So there's the current situation, some lightning here around South Bend, around Gary. Also northwest of Indianapolis. That's where the active cells are currently located. And like I said yesterday, you might see some odd weather patterns as a result of that jet stream not making its way down to the U.S. That will make for some oddities, like what we showed about the Florida weather and so on. You'll see it in the water vapor map that we'll close the video out with. Looks like Miami seeing some thunder rolling in there as well. Who knew it was so swampy just west of Miami? I had no idea. I'd never been to that part of Florida, actually. Anyway, there's your full lightning map from lightningmaps.org. Highly recommend it next time you hear thunder. And once again, if you enjoy the content, press like and subscribe. Thanks to our new viewers. Thanks to people who've been viewing these daily space weather videos for the last 6+ years. What can I say? Press the share button. Visit our links. Support the channel. If you don't support the channel, thank our Smash Team members for the existence of these videos. They are brought to you at massive personal risk and expense, mainly by Smash staff and I, but also by members of the Smash Team, especially Gold and Silver Smash Team members. So consider getting email alerts for yourself by signing up over there at Smash Team, smashomash.com/Smash Team. You'll find the links on the homepage. You'll find the links below this video. You'll find the links all over the place. Thanks again to Gold and Silver Smash Team members. There's even a bronze level there for all of you folks unable and or unwilling to open your cobweb-encrusted wallets and send us a few bucks per month to increase the probability these videos will remain existent, free for all to view, and publicly visible. We're going to close out the video with some more current weather data. And let's take a brief look at these strong storms around Chicago. So there is the scenario as they move toward Lake Erie and into Pennsylvania. Just about to enter Ohio here as we produce the video. Here's your full 50-state view briefly. We'll focus on the lower 48 view, chiefly. Here is clouds and fog. Once again, 3.9 micrometer infrared radiation, the shortwave radiation map from the NASA GOES Interactive Weather Satellite Suite. And here is the water vapor map. It shows all the water vapor, and there's a scissors motion happening right here. You see that? There's compression happening. There's dry mass of air moving this way and dry mass of air moving this way, creating big-time pressure gradients. and causing precipitation, causing dew point to be reached. We've also got a little bit of an impulse over here, and some rapid cloud nucleation happening here in northern Illinois. Anyway, here's your recap to close this thing out. U.S. Doppler radar. Shortwave radiation. And water vapor. When your Doppler is not clear as to what will happen, understand atmospheric physics, break out the water vapor map, and impress your friends and foes by forecasting things like airplane flight turbulence and why pressure gradients create precipitation. Anyway, it's about time to get this thing uploaded and onto your screens. Thanks to everybody who tunes into our live premieres. Again, press like, subscribe, share, comment, etc. Visit our links. New merch about to come out, so check out the merch shop. New merch will be coming out probably later today. Once again, thanks for tuning into the Smash News Network, least busted name in news. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.